Okay, so now let's double check what Excel gets. And let's learn some of the Excel formulas. So first, the mean is in Excel. Okay, so the mean, the formula is average. And then we have to read in the range, which I do with just highlighting with the mouse. Okay, so that's the same. What about the median? And yeah, the median, so the formula for the median is equals median. Now we need to read in again the data, which is already sorted, of course. Okay, so that's also the same, 7.5. What about the mode? Equals mode, that's the formula. And then we get 8. So now the 20th percentile. Okay, so we use the formula that the index numbers 0.2 times n, and then whenever it is not an integer, we round up. So if we did 0.2 times 8, we got 1.6, not an integer, we round up. So it's the second value, we got 4. So the Excel formula, however, is different. And so let me write that here. Excel formula for percentiles. So the index that we need to identify is given by the formula I equals the percentile that we want, like 0.2, times n minus 1, the number of observations, plus 1. Okay, so now for the 20th percentile, what do we get? So we search for percentile, and you see you get two formulas, percentile.inc and percentile.exclude. One stands for exclude, the other one stands for include. What does it include? Well, what you typically want is you want to include the highest and the lowest score. So most of the times you want this formula. There's not really much of a reason to exclude the minimum and the maximum other than for very specific circumstances about which I at the moment couldn't really think of. So I'm very sure most of the time you are using percentile.inclusive, which basically includes all the observations. If you have a super large data set, it doesn't probably make a big difference, but yeah, you want the percentile.inc, and that corresponds to that formula. Okay, so now we get, so we have to read in the array, and then comma, so what percentile do I want? I want 0.2. And now we get a value of 4.4 as opposed to 4. So what did Excel do differently? Well, what Excel did is it calculates the index number. So let's do that here. So Excel does the following. It wants to calculate the 20th percentile. Okay, so what's the index number that Excel looks up? So Excel determines the index number as 0.2 times 8 minus 1, which is 7, plus 1, which is 2.4. Okay, so now 2.4, Excel just doesn't round up. Excel thinks, okay, what can 2.4 be? So then Excel says, okay, at 2, we have the value of 4. So the value that Excel returns is the 4 from the second. But then it adds another 40% of the difference between the fourth and the fifth value. So, I mean, between 4 and 5, because the third value is 5. So it takes 40% of the difference between the second and the third value. So it does 5 minus 4, and then we get 4 plus 0.4 times 1, 4.4, which is this one. You can see if we use this formula for the percentile or the median, it's the same thing. So then for a case for the median, which is the 50th percentile, we identify the index number according to the Excel formula, 0.5 times n minus 1, 8 minus 1, 7, plus 1. So now we get 3.5 plus 4.5. Okay, so now Excel looks up the fourth value, which is a 7. So the value that Excel returns is the 7 plus 50% of the distance or the difference between the fourth value and the fifth value, which is a difference of 1. So 8 minus 7, and then we get also 7.5 in this case. Okay, let's do the 75th percentile. Again, we use the formula percentile inc. We read in the array, and now we just say 0.75 or just 0.75. Okay, so now we get 8.5, whereas with the simple textbook method we just got a 9. So let's double check what Excel did using this formula here. So the 75th percentile so first we need to find the index number I. The index number I is 0.75 times 8 minus 1, 7. Yeah, let's do it like before. That should be 8 minus 1, by the way. There was a typo I just noticed. Of course, that is... I know for the value that was correct, sorry. Okay, 8 minus 1, or the 7, plus 1. Okay, so what is 0.75 times 7? Well, we can use Excel quickly here, equals 0.75 times 7 plus 1. So we get 6.25. So the value that Excel returns is the sixth index number, which is 8, plus 0.25 of the distance between the 6th and the 7th, so that's 10 minus 8, which is 2, so we get 8 plus 0.25 times 2, which is 8.5. So this is just in case you ever wonder if what you see in textbooks may not necessarily correspond to what Excel prints out. But here, so now you know this is the formula for that Excel uses, at least when you use the percentile.inc formula, which you most likely will use most of the time. And again, once you have a very large data set, the differences become negligible anyhow. Okay, there's one other thing about Excel formulas. So the median is also the 50th percentile. So I can also write 50th percentile, and the corresponding formula would be equal percentile inc. We have again the array, and now we will say 0.5. Okay, then we get 7.5, which is the median. There is also the quartile. The first quartile is the 25th percentile, so that's the same as the first quartile. So 25th percentile. Then we can use the formula percentile and then 0.25. That's 4.75, and that is the same as the first quartile. So the first quartile is the 25th percent, and there's also an Excel formula, quartile, and again you take inc, inclusive, array, and then the first quartile 1, close parentheses. So the second quartile is equal to the median, or the 50th percentile. So we can again write quartile dot inc, open parentheses, comma, now the second quartile. So that's the same as the median or the 50th percentile. Then the third quartile is the same as the 75th percentile. So formula would be quartile the third, and that should be the same as the 75th percentile, 8.5, 8.5. Okay, so this is how Excel does it, and the other one is how you can find it in some textbooks. The textbook solution is a little bit maybe easier, even though the Excel formula is not that super complicated either. Okay, so let's just stop here, and then let's continue the next video by talking a little bit more about the relationship between mode, mean, and median, and when to use what.